Hello, everyone. Welcome to PureChem, a website designed for studying AP Chemistry and Yusenko. I'm Cosmo Wu, one of the three developers who made this website, the other two being Chetan Gorantla and Siddhartha Tella. In this video, you will learn how to navigate through this website. This website has four sections: a reaction calculator, titrations, solubility and melting point predictions, and a question bank. Let's get started with the reaction calculator. Use this calculator, you simply input the chemical reaction that you would like to analyze. There are two types of reactions that you can input, either a normal reaction, as the one above here, or a redox reaction, where you have to click the check mark box in order to use. We will start with a normal reaction for analyzing. First, let's put in a combustion reaction. We first input the reactants CH4. We can include the states if we like to. Include space in between all the elements. Afterward, we can press balance equation to get the balance reaction. As you can see here, this is our balance equation, and we already have the states for each of the compound in the reaction, even though we didn't input it here. Note that if we inputted original coefficients for our reaction, this will not affect our original result. Down here, and if we scroll down, we'll see the thermochemistry or the thermodynamical data of this reaction. We have the change in standard free energy of the reaction. We also have this change in standard enthalpy of the reaction. And lastly, we have this change in standard entropy of the reaction. We also have the equilibrium constant here, but we can modify this to any value we like. For example, we can enter 45, which will be used later on for the ICE calculator in this reaction calculator. Next, note that we can change the compound's state into whatever state we like to. For example, we can change the state of stage 4 into solid, and we can also make the state of oxygen into gas. And we can also input any coefficients that we like to initially. We can press the balance equation again, and we still get the same results. However, note that we wouldn't have the thermochemistry data that we had when we entered stage 4 as a gas. This is because that the data library that we use for calculating those thermochemistry data would not have stage 4 available, which leads to us not having data yet for these numbers. Before we take a look at the BCA and ICE table, let's take a look at using the redox reaction balancer. First, we enter our redox reaction. We will use this subscript for representing ion charges. Note that when you press balance equation, it shows that balance equation is not applicable. What you have to do is you must scroll down to redox reaction, the redox checkbox, click on it, and then you can either balance this reaction as an acidic environment or a basic environment. Let's try acidic first. As you can see, we have our results. As you can see here, we have both of the half reactions. This is the first half reaction, and this is the second half reaction, and this is the final balanced reaction of the redox reaction. We can also try this with the basic environment. As you can see here, we now have the basic reaction balanced. Note that as you can see here, some of the states is represented as N instead of L or aqueous. This is because when trying to figure out the state of these ions, the data library was unable to find an actual state for these ions. In order to fix this, we can simply add a Q. And if we do this again, we will see that the state is now here. We will now demonstrate how to use the BCA calculator and the ICE calculator. First, let's balance an equation. For this example, we will be using a normal reaction. However, note that the ICE and BCE calculator also work for redox reactions. Now that we have our balanced reaction, let's try out using the BCA calculator. If you don't know what a BCA or ICE table is, you can search them up if you like. But first up, we'll talk about the BCA table first. The BCA table is basically a technique or strategy used for solving limiting reactant problems in stoichiometry. For example, if we have zero point 0.5 moles of C2H4 and zero point 0.5 moles of O2, we can press the BCA button here to see how many moles of CO2 we have and how many moles of H2O we have, and also how many moles of reactants we have after the reaction occurs, assuming that this reaction goes to completion. You can also try other units on these type of inputs. For example, we can do 16 grams of C2H4. However, make sure that after you input the number, add a space and then put grams or G. You can see that we have new results now for our answers. And we can also have initial amount of products for this reaction. You can have zero point 0.5 moles of CO2 and zero point 0.5 of H2O. If we do not include units in our input, the BCA calculator will assume that the unit of this number is moles. And finally, we can also input our units as molarity using the volume here, which will be assumed as liters. As you can see, we still get the same results because for H2O, there are still only zero point 0.5 moles of H2O initially. Next up, we will look at the ICE calculator. What the ICE calculator essentially does is by using the K value or the equilibrium constant given here, it will find the final concentration of all of the compounds in the reactant and the products after the reaction reaches equilibrium. For such a big K value as for this reaction, it will assume that the reaction goes to completion. So for the example's purpose, we will change this K value to 45. And similar to the BCA calculator, we can input any any units we like, whether it be molarity, grams, or moles. After we input the units and the numbers, we simply click on ICE to get the new concentrations. As you can see, we have captions here saying that this reaction is a forward reaction, which means that in order to reach equilibrium, the reaction is going to shift this way. Note that we can also modify the volume here and change it to any number we like. For example, we can change the volume to 5. If we press ICE again, we'll get different concentrations this time. And also, if we make the K value a little bit smaller, for example, 4e negative 9, which is equal to 4 times 10 to the power of negative 9, we get a reverse reaction, like such. Now also, on another note, if we make the K value extremely large or extremely small, the calculator will assume that the reaction goes to completion when it reaches equilibrium. As you can see here, the number of moles of O2 or the concentration of O2 is now 0, meaning that the calculator assumes that the reaction goes to completion and uses up all the O2 moles in order for the reaction to reach equilibrium. Note that sometimes if we have inputs where, for example, the initial concentration of all the gaseous compounds is 0, we may not even get a reaction. As you can see here, nothing changed. If we press again, we see that the captures no reaction. This is simply because for the Q of this reaction would be undefined or indeterminate. So for this reason, there wouldn't be any reaction to occur in the first place. Finally, one last note to consider is that when the state of a compound is N, it will still be considered as either gaseous or aqueous. For example, here a reaction is C2H3, which is a compound that doesn't exist, and so the data library wouldn't be able to actually assign a state for C2H3. And for this reason, it will still be counted as either aqueous or gas and will thus be used in the ICE calculation algorithm and also part of the Q expression. Next up, we will look at the titration section of the website. This section has two parts, calculating unknown molarity and calculating unknown pH. The unknown molarity section is used to calculate one of the unknown concentration of either the base or acid after the titration has reached the endpoint. Let's take an example. Let's try using the initial acid concentration where we know the initial concentration of our acid, but we don't know the initial concentration of our base. We first enter our concentration, which is assumed to be molarity for our acid. Then we enter our initial volume of our acid and the final volume of our acid after the titration has reached the endpoint, and the units for the volumes can be any units as long as the initial volume and the final volume has the same units. And here, we can enter the number of sig figs we want our answer to have. We press calculate and get the answer we want, which is 2.1 molarity for our unknown concentration of base. This works the same way for initial base concentration, so we'll go on to the pH section next. Next up, we will talk about the pH calculator of the titration section. Here, we have a drop-down. We can either titrate a weak acid with strong base, which essentially just means that we're adding a strong basic solution into an acid solution. Here, it assumes that we know both the molarity of the acid and also the molarity of the base. And if we're titrating a weak acid or titrating a weak base, we would need either the Ka value or the Kb value. However, if we're titrating a strong acid or a strong base, we wouldn't need them. Let's take an example with titrating weak acid. Here, we'll first have to enter our Ka value. This is self-explanatory. Let's just enter a random value, 5.6 times 10 to the power negative 9. Then we'll have to enter our initial volume of our acid and also our initial molarity of our acid. Here, we can enter the initial volume and note that it must be in liters. So let's say 0.50 liters. And also 0.40 molarity of acid. And this will also be assuming that the molarity is in the correct units. Next, we do the same for our base. And again, we can also choose how many sig figs we want for our answer. So let's do 3. As you can see, we get the correct value that we wanted, 12.64A. Note that this might look like we have 5 sig figs, but there's only 3 because remember, pH, we count the sig figs after the decimal point. So right here. We also get a little bit of a caption here saying that as excess base. So it allows us to know which region of the titration we're at. We can also do a similar thing with weak base with strong acid. But let's look at titrating a strong base with strong acid, which will be similar to titrating strong acid with strong base. Since we still got the same values, we can just press calculate again. And we also get the value that we wanted to see. So this is extremely similar to the other drop downs. And that's pretty much it for the pH calculator. We will now look at the melting point predictions and the solubility predictions section. This section is very self-explanatory. We will enter elements or compounds into the section separated by space as such. We'll enter carbon and NaCl. Then we can press submit. What this does is it takes the compounds or the elements that we have and arranges them from the lowest melting point compound to the highest melting point compound or element based on the melting point. We can also enter more compounds or elements as well. We can enter as many as we like to. We can also do something similar for the solubility. We can enter a compound that will dissolve in water and then rank them based on how much they will dissolve in 100 gram of water or 100 milliliter. So you can see it ranks them from the lowest solubility to the greatest solubility. One thing to note about these ranking predictions is that if you enter something that may not be in the data library, it will simply not appear within the ranking. Here, CNO is part of the melting point dictionary, so it will appear here. However, if you include CNO, nothing will happen to solubility as we don't have any data yet for solubility of CNO. Finally, we have a section where there is a question bank for each of the core topics of AP Chemistry. To use this section, simply click on one of the boxes to start. You will be presented with the question, and there will be buttons to show the answer and to show the solution. In order to go to the next question, click on the next question. You can continue going through all the questions until you have seen all the distinct questions. And by then, you'll reach to the same question once more. That is the end of the showcase of this website. Thank you for watching this video, and we hope you enjoy this experience on the website. Bye bye.